Let's take a look at some more stoichiometry mole problems. Okay, and this sample problem says how many grams of hydrochloric acid, which is HCl here, would be required to react with 5 grams of sodium hydroxide. Okay, so first of all, before we do anything in for this equation, the first thing we need to do is to write out the balanced equation for this reaction. And I know that my hydrochloric acid, which is HCl here, would react with NaOH. We don't know the number of moles of HCl that would react, but we know it reacts. And this should give me, sorry about that, this should give me sodium chloride, NaCl, plus water, H2O. Okay, now this equation is balanced, right? So let's quickly take a look at how to solve this question. It's quite simple and straightforward. Now, the next thing you want to look at is this. If you're given the mass of any compound, you need to find the number of moles of that compound. That is usually the next step. Okay, so I'm going to be saying that my number of moles, which is equal to my mass over molar mass, will give me my 5 grams divided by the number of moles of sodium hydroxide. Note that my sodium has a relative atomic mass of 23, plus my oxygen is 16 and my hydrogen is 1. This will give me a total of 40 grams per mole. Okay, so this will be divided by the 40, and I am going to have 0.125 moles. Now, I know the moles present in sodium hydroxide. Now, in the equation, if you look at it properly, you realize that 1 mole of hydrogen reacted with 1 mole of sodium hydroxide, isn't it? In that case, if 1 mole of sodium hydroxide equals 0.125 moles, then that tells me that 1 mole of hydrochloric acid should also be 0.125 moles. Why? Because they have the same amount of moles here. If I assume that this is 2 here, then I am going to be telling you that 2 moles of hydrochloric acid reacted with 1 moles of this, and then I'm going to be multiplying this by 2. Okay, but since they both have 1 moles each, it's just the same. All right, so let's move forward. Get more space. All right, so my next step in calculating this is quite straightforward. Since I know my molar mass of hydrochloric acid to be, my hydrogen is 1 plus chlorine, which is 35.5, this will give me 36.5 grams per mole. All right, now that I have this, it's quite straightforward. Now I know this is a molar mass of hydrochloric acid. Then my next step is to just multiply my moles, which is 0.125, then multiply by the molar mass, 36.5. Okay, I'm gonna write this in a proper form so you'd get it. Okay, now let me briefly explain again. Since I have my mole of hydrochloric acid to be this, and my question here says that how many grams of hydrochloric acid. Now, if I was looking for the moles, how many moles, then I should actually end my answer here. But because I'm looking for it in grams, what I have to do is to multiply my moles with my molar mass, and I'm going to get my answer in grams. Okay, so the formula I'm meant to use is the number of moles for the HCl multiplied by the relative molecular mass of HCl, and this would give me 0.125 multiplied by 36.5, and my final answer is gonna be 4 um 4.56, approximately 4.6. This is my final answer in grams. It's quite easy and straightforward. Let's take the next question. This question says the burning of phosphorus in excess oxygen is represented by this equation right here. And then it says what is the volume of oxygen at STP required for the complete oxidation of 18.6 grams of phosphorus. Okay, let's take it straightforward. Since I have the mass for phosphorus, I should quickly look for the number of moles like we said. My phosphorus is P4, and that simply tells me that I'm going to be looking for the relative molecular mass. My phosphorus has the relative atomic mass of 13. Sorry, the relative atomic mass for phosphorus is 31. So let me just erase this out. Alright, so I have 31 here. Now I'm going to be multiplying this by 4 because it comes in 4 moles. And this is going to give me 124 grams. Now, moving forward, I already have my relative molecular mass for phosphorus. Now, the next step for me is to be finding my number of moles, which will be 18.6 divided by the 124. Okay, and this is gonna give me a final answer of gonna have 0.15. There's a point here, 0.15. Okay, that's good. Let's move forward from here. This is in mole. Now, from this equation, you'd realize that 1 mole, why am I writing this way? Okay, so you realize that 1 mole, okay, of phosphorus, okay, P4, requires 5 moles of oxygen. If you look at it this way, I have 1 mole of phosphorus here and 5 moles of oxygen here. Do you understand? Now, this makes it easy for me. So therefore, if I'm going to be looking for the number of moles that phosphorus is going to need, then I'm going to be multiplying the 0.15 by 5. Okay, now this is going to give me 0.75 moles of oxygen. This makes it easy and straightforward. So from here, let me get some space for me. So from here, I just have to look at it this way. Since I'm talking about gases at STP now, I know that 1 mole of oxygen at STP, so that's 1 mole of oxygen should be 22.4 dm cube. That's the volume it occupies, right? And for me to get my final answer, it should be 0.75 moles multiplied by the 22.4 dm cube. And my final answer should be 16.8 dm cube. Now, and that is the volume oxygen occupies at STP to oxidize phosphorus. It's quite easy and straightforward. Let's take another example. Okay, so from this question, we see that 500 grams of a mixture of CaCO3 and CaO liberated 1.32 grams of carbon 4 oxide on strong heating. Now it says what is the percentage of the calcium oxide in the mixture. So we are looking for the percentage of this. Okay, this, right? So our compound is this and carbon dioxide, which is CO2. Okay, it's quite easy. Now, first thing we need to do is to write out the equation for this. I have my CO3, okay, and this should decompose upon eating to give me CaO, then plus CO2. Quite easy and straightforward. Note that I have the mass for my carbon dioxide. So the first thing I have to do is to look for the number of moles for carbon dioxide. And the mass is 1.32. If you calculate the number of moles for carbon dioxide, you realize it's 44 grams. Okay, and this will give me 0.030 mole. Now, from the equation, I know that 1 mole of CaCO3 gave me 1 mole of CO2. In that case, 1 mole of CaCO2, that means CaCO2, CO3 rather, should also have 0.030 mole. Are you getting it? We've been doing this over and over. I hope it has stuck now. Alright? So now let's move forward. The relative molecular mass for CaCO3 is 100 moles, 100 grams per mole. Okay? In that case, I have to multiply this 100 grams per mole by the number of moles it existing for me to convert it into grams. So I have 0.030 multiplied by 100. This should give me a sum of 3.0 grams. Now, the mass of CO2 in the mixture is 5 grams. I'm going to subtract the 5 grams from the 3.0 grams I just got now. And this will give me 2 grams. Right? Great. So for me to get the percentage of the CaO in the mixture, I have my 2 grams divided by my 5 grams. Then I'm going to multiply this by 100. And my final answer should give me 40%. Now, the way I solve this, my method of solving this might be a bit confusing, but you just need to follow it up. The question is simple. We are looking for the percentage of CaO. Okay? So, all we actually had to do, first we found the number of moles of carbon dioxide, we converted it into grams, okay, and then we have this. Now, because I knew the mass of carbon dioxide, all I had to do was subtract it from this amount to get the mass of CaO. Once I had the mass of CaO, I knew my percentage was easy to be found. That's the mass of CaO divided by the total mass of the compound, then I'll multiply it by 100, and then my final answer comes up. Thank you for watching this video. My name is Lafex. Have a lovely day.